Welcome to the demo on the DevOps, SRE, and cloud computing concepts. We're gonna talk about all these four concepts primarily. We will talk about what is infrastructure, what is platform engineering, and why DevOps has become this so huge in market. And then what is cloud computing, how DevOps and cloud compute is related, and then what is the site reliability engineering, where you will be managing the observability toolings, logging, monitoring, and other stack around. So we will be learning about all these four concepts today. So why you have to learn cloud computing, DevOps or SRE or any of these stack? So right now, DevOps or SREs are the most demanded profile in market right now. So with having these evaluation in terms of artificial intelligence, and then in terms of that no code toolings implemented in market. So earlier there used to be a little priority for the developers and stuff like that, but with the AI enabled tooling, without a developer, if you have a proper DevOps engineer and SRE engineer, you can build a product. That is the level of maturity we are in right now in market. That is why you are seeing a lot of companies, they are getting rid of the testing engineers. There are no manual testers these days. There are no actual automation. I mean, everything has been automated, and then automation is one of the key part of DevOps thing. So that is why DevOps has become like very high demand in market from last 10 years. I think it will be in high demand for next couple of years. And then learning these stack will definitely help you to upscale your job. So no matter what profile you are in an organization, somewhere or other, you will have to get in touch with these tech stack. Like you have to deal with cloud, you'll have to deal with DevOps, DevSecOps, whatever your company names it, right? And then there is a very minute difference between what is DevOps engineer does and what is a site reliability engineer does. Okay, we will eventually learn that in today's demo, but it's again a company specific thing. In some company, they say that platform engineer, but that he would be doing some sort of DevOps work. In the other companies, he would be doing the infrastructure engineer. He's gonna do something with the SRE. So these names are not really intact, or there is no predefined job role for all of it. It will all fall under the same versatility. That is what my second point is all about. So that's my point about versatility, right? Learning these skill will allow you to fit in anywhere in any role under the whole domain. And then innovation is in another way. There is a scope for a lot of innovation. Like today I am a DevOps engineer, I join a company, there was an existing workflow, I have an ample opportunity to redo it. I mean, making it better, adding a lot more automation, because these tech stacks are keep on changing. Earlier we used to use Jenkins for CI/CD. Now if you are into Kubernetes, you will be asked to use the GitHub Actions, or you will be you will be asked to use the Argo CD tool, right? So there is always scope for innovation. There is, like, it's not like there is an existing stack, you have to live with it. In DevOps, that is one advantage and one feasibility. So whatever stack is there, you can always do an scaling up, getting it to the better version of things, because most of the tools we use in DevOps are open source, and the most of those tools are keep getting updated. Like every time, every they come up with a new release, they will add new features. So you always have that scope to learn and act innovatively and automate your stuff inside it. And then salaries. Obviously, DevOps or SREs are highly paid jobs in Indian market from last 10 years. Yeah, I think that the reason why you should be getting into the DevOps, cloud computing, or cloud platform or infrastructure engineering role set in market today. So what are the prerequisites needed for someone to become a DevOps engineer, right? So you will have to you will have to have at least a basic system administration knowledge, right? And then basic networking concepts. When I say system administration, you need to have a bit of understanding on what is your platform, what is your operating system you are managing, how to install softwares on your operating system. It can be a Windows based operating systems or Linux based operating system. How you are managing your operating system, software installation, services installation, file management, securing your operating system in a way that it's less malicious, and then doing the patching and stuff like that. Those are the basic system administration concepts you will have to be familiar with. And then basic networking concepts as well, right? You also need to have understanding about how your network works. When you have an organization with 100 computers inside it, right? How a computer one is going to talk to computer two, how you can make how you can actually restrict computer one not to talk to computer two, right? How you are defining your network, how you are defining your vnets, how you are defining your routing, switching, and stuff like that. So you need to have that understanding, right? So it all starts with the IP addressing, giving an getting your system into the network, and then managing things in the network, and keeping your entire infrastructure secured and properly configured. So right, you always have to give right set of permissions. You should not over provision or under provision your network rules. So those are some of the concepts you will have to have an understanding. And then knowledge on platform and infrastructure, it covers, right? So basically how it works, you have an hardware, on top of it you have an operating system, on top of it you have your application runtime for your coding and development, on top of it you have your application running. So that is how infrastructure and platform works parallelly, right? So you will have to have an understanding about all of it, like what layer you are in, whether you are at a platform layer, whether you are at an infrastructure layer, what are the components inside the infrastructure, and then stuff like that. And scripting and automation, you would definitely need some sort of understanding on scripting and automations, because as a DevOps engineer, what ideally you would do is you automate the manual stuff that used to be done. There is a process of build and release, right? So a developer goes and try to build a software manually using the build tools, and then deploy it into a targeted environment. What you can do as a DevOps engineer, you would take that part, you would add an automation. So every time the developer wanted to do a build, you don't have to do it manually, wherein our automation will kick in, and then it will do the build and deployment of it. So for that to perform, you need to have some sort of scripting and automation skill set. And then knowing what is SDLC, a software development lifecycle, and how does it actually work. So software development lifecycle, yeah, let me maybe ask you guys this. How many of you are familiar with SDLC, software development lifecycle? So basically, what software development lifecycle does is, right, we have so many software companies there out there in market. Let us take Infosys. So tomorrow you started a small company, right? You started a small bakery company, and then you wanted a website for your bakery, right? So what you would ideally do, right? You will go ahead and interact with any of the software development company and ask them to build a software for your business, right? So your business is a bakery company, and then you have to get a software being built for your business, right? So that you can manage like you can go into the market, you can update your stock details in your website, and you can sequentially do, like when someone wanted to place an order of a bakery item, they can just go to your website, they place the order, and then they get their detail order being delivered. You manage that tracking and rest of the things. So that is your primary requirement. Right now you go and reach out to a company, so you will be called as a client, right? Because you are a client, you have a client requirements. And then when you go to the client, when you go to the software company, right, how does Infosys manages inside of it to handle your request? So they will have a team of people. They have a project management team, they have a development team, they have a testing team, they have a system engineering team. So they all work together to to deliver the software that you requested for. So how does it work is, the very first phase of it, they will come up and start doing the requirement analysis. Like, the project management team from Infosys get in touch with you, and then get the core details of your software, whatever bakery company you are running, and whatever website you wanted to have. They're gonna come and get all those requirements. That part is called user story. Here they collect all your requirements, and then they convert into a user story. Now they have the user story, they know what a user is required. And then what very next step, what do they do is, they go to their local development team, like they get in touch with the development team, they ask them to design it, right? When they design it, there are certain phases, like here they will check with, okay, what programming language we should use, right? So they will decide that, okay, what is the programming language we should use? Should we use .NET to build the code? Should we use Java to build the code? Should we use Python to build the code? They will decide the tech stack. And then they will decide, like, what is the front end looks like? How does the front end looks like? How does the back end looks like? And then how does the application or middleware server looks like. So they decide all of it based on these technical requirements. Now user requirements are converted into the technical requirements. After the technical requirements have been converted, they will get in touch with the local system engineering or network engineering team, and then they kind of ask them to set up a dev environment. So once the technical requirements are ready, then it goes to the local development team. They will come up with setting up the infrastructure, right? This is where infrastructure layer comes into place. So here you will set up a machine with Windows or Linux operating system on it, and then you will run you'll set up the application runtime, like, if the developer is going to build the software on a .NET, you will install all the .NET based .NET framework, or whatever Microsoft Silverlight or whatever tools required to build the code. Once this is all done, like, now this is infrastructure and this is the platform application runtime, and then they start running the code, and then once the code is ready, they test it. When the testing is done, when everything is goes fine, they will just involve the user and then ask them to check whether it is all okay with that. When user is say that, okay, this is exactly what I wanted, and then it goes to the deployment. When it goes to the deployment, this is where you will be deploying it into your environment. So it can be your production env, or your stage env, or your sandbox or pre-prod env. So these are called the environments, right? So how do they do it? They get the requirements. Once the requirements are gathered, they convert the user story into technical story by analyzing what are technical stack we should be using to build that software, and then they get into the implementation phase. In here, the developer will come in and then they start developing the code and testing it locally. So this environment is called their local dev environment. So they call it as developer environment and test environment. Right here, take a look at here. This is exactly how a software is being built in any organization, and I'm not talking about DevOps here. I'm just talking about how software development lifecycle works to build a software end to end. You go to a company with your requirements, and then they convert your requirements into technical requirements, and then they build their local platform, right, to support your requirement, and then they include the developer, tester, QA engineer, or whoever stakeholder, and then they get everything tested on their local, and then they get the confirmation from the customer saying that, okay, that is all he needed, and that fulfill his user story, and then it gets into the production environment. It gets deployed into the production environment, and then your site is ready. So here, once everything is up, your www.mybackeries.com is online. So you hit the mybackeries.com, and then you will be able to see your website. You have front end, you have list of your bakery items, you have a provision for your customers to log in and place orders and go so on and so forth. This is how the software development looks like. This is the prerequisite. But now you can think of it. Now this is all good, right? This is very straightforward. Everything looks very, very linear and easy to understand. Why DevOps comes into picture? How DevOps is adding advantage to this particular layer could be the question, right? As anyone know, why DevOps is needed when we have this software development lifecycle in place. So now this is the workflow, right? Exactly how software development lifecycle works. Now let's try to understand what is the disadvantages with this whole process, right? Now imagine the same story. A customer comes in, they wanted to have a website for their bakery business. So they say that, okay, when I hit www.mybakeries.com, I wanted my website to be up and my website to be running. and then customer is not like a techie guy, so he just says that is requirements. I wanted to list my products. I wanted my customer to log into my website and then place order of my items, and then it gets to the order cart, and then order being processed. They also get a message on their phone that their order is being transmitted, or once it is delivered, they get a message saying that your order is delivered, and so on and so forth. That is the customer requirements. Now you come over here, and then let's talk about the project, the stakeholders involved, right? So the very first stakeholders here is project management team. Here you will have one project manager or two project manager and client manager, right? Some companies they call project manager, some companies they call client manager, some companies they call business analyst or whatever stakeholder. That is one team which acts as a bridge between the customer customer, for them it is client, and the internal development teams. So beside project management team, who else is going to be here? So you have a development team. So here you have a developer, and then you will have one tester, right? A manual or automation or whatever tester. You will have the developer and tester on a very high level. Let's go with a very high level, right? And then who else will be there? You need a platform team, right? You need to support platform team who is gonna give you the infrastructure, right? So here you will have you'll have a system engineer to manage your network. You will have a network engineer, and then you will have a middleware engineer. You might have, like, if you are into software domain for quite some time, you might have heard about all these roles, but right now in market, like, these are the roles which are actually gone. But yeah, let's talk about it later. You have a database engineer to manage the database related stuff, right? You might have a build and release engineer who is going to help with building and releasing the software. This is the another tech stack, right? You have a development team, and let's call it as a platform team. Right now you have a project management team who gets the requirements. Development team, they convert, they decide, okay, what is the software we will be using. We have a stack of .NET developers, we have a stack of Java developers who and then customer requirements are easy to be handled in Java. How do they decide whether they wanted to build the software in Java or .NET or Python, Ruby, Perl, or whatever? Like, we have like n number of programming languages available, right? C++, there are so many programming languages. How do they decide, like, what is the programming language to be used, right? So when they get the user story, while the process of converting into the technical story, they come up with a decision. Okay, let's go ahead and build the software in this tech stack. And then they basically decide the tech stack, what tech stack we will be using to build the software. And then they take help from the platform engineering team to arrange or to manage this particular tech stack. So these are the guys, they start setting up the infrastructure. Now, when I say infrastructure, here you have dev environment, and then you have test environment, and then you have stage environment, which is a pre-prod environment, before moving your software into production. And then you have a prod env. So this is the transition, right? They build this tech stack in dev environment, right? So how do they do it? They basically create a virtual machine. Create a, so it can be a virtual machine, it can be an on-premises machine, or it can be it can be an EC2 machine or whatever, right? We were not going into that depth. We will talk about that in a bit. Let's say they set up the operating system. On top of operating system, what they gonna do? They set up the application runtime, app runtime. On top of it, they deploy the app code, the binaries and libraries of whatever, right? So when they deploy it, so when they test everything on the dev environment, and then they move it to the test environment. When it goes to the test environment, this is where our QA engineers, so this is where the QA engineers will come into the place, and then they start running the test codes, test cases. So they use the Selenium test cases. They use any kind of test that supports this tech stack, and then they start writing the test scenarios. and then they set this up. They have to, this engineering team, platform team is supposed to set this whole thing in the test environment as well. And then on top of it, they will run these test cases. Once everything is fine with these test cases, right? And then they will call customer client for a pre-check by moving the entire stack to the stage environment. When it goes to the stage environment, it is the same stack. You set all of it. On top of all of it, you run this application and you include the client verification. Once everything is fine with this application, then when the client says that okay, my application is all good, now we can move it to the production. And then they will promote the same application into the prod environment. Here it is the same thing. The same application with app runtime and app code will be there, and then it is pointed to that website called www.mypackages.com, and then it is all good. Customer is happy, and then you have a working solution. Your project has been delivered. This is the stage when you say that project has been delivered. Now the problem is after 6 months of time, right? If the customer comes back to you and says that okay, my website is working fine, now there is a Deepavali event is coming or Dasara event is coming, I wanted to add some offers, right? And or I wanted to add some more bakery items into my cart, into the cart, right? Are there any other changes? So E has come up with a new set of requirements. Now you will go back to the stage one, requirements gathering. So since this whole thing was done manually, here there was not much automation. It was manually done with these many stakeholders. You have project management team, development team, testing team, platform engineering team, and so on and so forth, right? So many stakeholders involved. And then they build this version one of the application. So this is going to be version 1 of the mybakeries.com. Now you need a mybakeries.com version 2 with above changes. So, and this requirement has come after 6 months or 1 year, for that matter, for you to understand the real situation, right? So now what happens? Let's try to understand the real time situation. Now within these 6-7 months of time, the actual project management team who has actually worked on this project, they might have left the company, or they might have assigned to another project, right? It can happen. The developers who are involved in building the version 1 of the software, they might left the organization, or they are engaged with some other project where they cannot work, they cannot come back and work on the mybackways.com version 2. And then same with platform engineering team, because a system engineer develops local environment, and the network engineer manages the stage or production environment. Build and release management engineer manages the building and deploying of the application. He has no idea where is the infrastructure for this stage environment or test environment or the dev environment, and there is no idea, no documentation. Here the problem is no automation, and then no documentation. So you don't know how the software has been built. The first thing is, and then there is no automation runbook that you can reuse to regenerate the whole thing, because, and then you will fall into the same loop. You get the requirements, you integrate a new project management team, or generate the existing project management team, and then you integrate with the infra and development teams, and then with all the stakeholders, and then start digging into it and finding where is the existing code, how that is built, and so on and so forth. That is called reverse engineering. So every organization, right, without DevOps, when they wanted to make changes in a existing software, they have to go with this reverse engineering process. It takes a lot of time, and in a real time situation, it is always high important to keep your version 1 up and running. So it is always a risky thing to make changes and test things inside a production environment when you don't know how it is actually built, how it is actually deployed, without having a proper documentation and all. this process is there, right? Whatever user story conversion into project management and then getting into the infra team, dev team and stuff. This project management process is called waterfall methodology. So before DevOps, every organization is used to follow this waterfall methodology. And then when they wanted to make changes to the existing software, they, because there was no automation or documentation on the version 1 of the application, they always used to do the reverse engineering and trying to invest so much time to understand how the code works, how it is being built, and how it is being deployed. Because waterfall methodology doesn't talk about automation, it doesn't talk about documentation. Waterfall, like, as go with the flow kind, right? When there is a requirement, just go with the flow, engage the team and get the job done. So that is the biggest letdown. That is where software companies are struggling to build the software error free or in a fast phased manner. So this is the problem statement. As a solution to it, we have DevOps comes into existence in 2012 actually, but it slowly get into the actual phase at 2015. Now we are in 2025, and then every organization in market right now is using DevOps organization. You don't see an organization where there is no DevOps engineer, right? That is how the evolution happened. But I will help you to understand how come DevOps is actually resolving this problem. Now we know the problem statement. Let's talk about solution. How DevOps is actually solving this whole problem. Now you go to this entire section, take all of these guys and replace them with one DevOps engineer. So here you will be sitting in as a DevOps engineer. So how you gonna solve this problem is what I'm gonna explain right now. So same thing. Let's go back to the same situation where you have a client, they have a business, mybakeries.com. They come to your company, and then you are here, and then you need a project management team. So you have a project management team, you have a development team, developer and tester team, and then you have a DevOps engineer. So how you gonna address this whole issue? Now let's see this. So in the very first phase, you divide the entire user story into sprints. So what you gonna do? You user story, you convert them into PDBs, project backlog items. I'm just saying it in a one way of handling it, right? So you divide that into sprints. Let's say sprints. So you say that a sprint is a work of 1 week to actually 2 weeks or 14 days, 10 to 14 days. No. Uh, okay. So a sprint is a matter of 2 weeks, 2 weeks of work, right? So what you're gonna do is you convert that user story into technical requirements, and then each technical requirement you gonna handle them in terms of sprints. How do you manage the sprints? You use a agile board or a scrum board or a sprint board. Here you are integrating a tool called Jira project management tool. So here you first create a sprint one. In this sprint one, you create a task, and here the task is build the front end and assign it to the engineer, whoever developer, right? Assign it, right? So and then you keep going with this approach, like, and then you go to the sprint two. Here build the back end. Here each task as a assignee, and then it has a history. And what is the task? What is the subtask? Like, task can be again divided into subtask. Why am I stressing on this? I'll explain you in a minute. But just try to follow me. Right. In the sprint two, you build the backend. In the sprint 3, you go ahead and build the integration of front end and back end. Back end. And then, in sprint 1, to create one more task. Sorry. Right. So infra setup. So you are a DevOps engineer. This has been assigned to DevOps guy. So you set up the infrastructure. Here, how do you set this infrastructure is something you will be learning as part of text tools. But now what are we making sure here? We have a track of the entire workflow. How we are building the software in sprint 1 of a 2 weeks time, what we did. In sprint 2 of the 2 weeks time, what we did, and what all tasks we have worked on. Who is the assignee worked on that task? What is the outcome of that task? Where is the task artifacts? Everything is documented. So this part is actually answering the problem that we had earlier, which is the documentation. You don't know how the software was built, where the software was built, where are the artifacts and stuff like that in waterfall methodology. That issue has now been addressed with the agile project management team. Now this is one part of it. So here let's ignore about the development thing. As a DevOps engineer, what you gonna do? Here, your role is to set up the dev environment. So dev env. So what do you do here? You write a infra as a code. So you use some Terraform module. You automate entire development infrastructure. So what you do is when you run the Terraform code or infra as a code, you use the Terraform module, or you are on AWS, use some CloudFormation templates, or you are on Azure, do some ARM templates, or you are on GCP, use some Google templates and some Google templates, or whatever it is. You automated the code of how the infrastructure brings up, right? When someone hits that module, when someone hits that module, it will create a virtual machine, VM, install the software, application, runtime, create VM, create network, right? Set up security tools, right? And install application and its runtime. This is your infrastructure code. Now you automated all of it, and then you call it as a dev environment, and then you give it to the developer to start, using it as a dev thing. Now, once he is all okay with it, he says that, okay, I'm good with this development. I built the software, everything is working fine on my local JUnit, local unit testing. Let's promote this to the next environment. Here comes the test environment. You don't do anything much. You use the same infra as a code template because this is your automation. You automated all of it, and then you will be using this part to bring up the test environment. So now you're solving a biggest problem here. The code works in one environment, not works in other environment, because when in a manual environment, there is always high chance that when they are moving the code from one environment to another environment, it might not work because of the operating system dependency changes, or the software dependency changes, or anything platform related changes. There is always have to have a problem called code works in one environment but not works in other environment, because tester is not going to have access to the developer system, and developer might not have access to the testing environment or a pre-production environment. When these stakeholders are trying to move the software from application from one environment to another environment, they always used to fall into the situation called code is not working on the other environment when it works on developer environment. So that biggest issue you are solving in the DevOps, because you automated that entire infrastructure, right? If it works in dev environment, it will work in test environment, because you are setting up the same exact dependencies, resources from your dev environment to the test environment. Once everything is fine here, you're gonna move it to the stage environment. So if it work, if your application is working fine in test environment, it's going to be stage environment. Once it is all fine in stage environment, and then it will be promoted to the prod environment. Here, two major problems we have addressed: automation. You exactly know who has worked on what, how did they work, where are the artifacts of that work, and then how it is being built, how it is being deployed, so on and so forth. You have a complete complete workflow from how the software is being moved from one environment to another environment. So here, what you want to do, you will set up some sort of Jenkins. So what you do as a part of DevOps engineer, you want to create a CI/CD pipeline. You say that I create a Jenkins, and then here is the developer. So developer, he he builds the code, and he push it into a version controller. Here you say that version controller. So here you say Git, GitHub, so on and so forth. So as a developer, when he builds and push the code, right? When he push the code from his local machine to the version controller, you are invoking your Jenkins pipeline in a way that Jenkins take that code, no, it connects to that version controller. It invokes multiple phases: build the code, test the code, and deploy the code, right? And monitor operations, monitor the code. Now, for this to achieve, Jenkins is integrated with multiple tech stacks. Like it can use Docker, it can use Kubernetes, it can use your build tools, right? It can use VMware, it can be integrated with your cloud, which is your AWS, GCP, or Microsoft Azure, or so on and so forth, right? It is a entire pipeline. When you have a code change here, it is being tracked in the GitHub. Jenkins is configured to take the code, build it, and deploy it into your target environment. Now imagine the software version 1 is ready. After 6 months of time, the same customer comes back here saying that, okay, I need some changes because there is a big billion day sale or a Deepavali offer. I wanted to add some more items to my catalog. I need www.mybakeries.com version 3 with few more changes. Now, when they come back here, it's not the earlier situation, friend. It is the DevOps, where you know where is your code, how it is being built, where it is deployed, so on and so forth. You have access to the dev environment, test environment, stage, and prod, because here you are the guy who manages this whole thing. So this is how the infrastructure evaluation has happened. And then containerization, cloud and containerization. So right now we are in a generation of containerization, cloud and containerization. No one is building their application in on-prem, on local machines, right? Where you use that, the on-prem location servers and manage things manually and stuff like that. No one is using VMware right now. VMware is also kind of about to die technology. So people are using cloud. People are using containerization. When you go to containerization here, we will have to talk about things like, what is a legacy application, what is a microservices application, right? How do you build a microservice application? How do you convert a legacy application into microservice when you wanted to deploy this microservice application, right? Which is a Docker application. Here you will have an option to deploy it in K8s. You have an option to deploy it in OpenShift or any other container platform. This is where it comes. Okay. I'm just giving you the whole idea. I mean, like to explain how DevOps engineer is enabling and helping companies to build the faster and less bug-free softwares. After some time, your customer comes back and says that I need a new changes. So at this point of time, you don't need to do this reverse engineering thing, or you don't fall into the situation where code works in one environment and not in other environment, because here everything is automated. And right from your dev, test, stage, prod, all the infrastructure is properly automated by the infrastructure as a code tools. And then if the code change, you make a code change here, and then let Jenkins build that and deploy that into a dev environment. Here, what you gonna do? Let the code being deployed into the dev environment, and then you test it in the dev environment. If it is all good with the new changes, and then we will promote that into the further environments, which is prod or pre-prod or prod. So here, what are we achieving? We are achieving a faster turnaround of your software development. So for companies like Infosys, Dell, IBM, to make a small image change on an existing software without DevOps, they used to take SLA. They call it as an SLA, like a service level agreement to kind of done a particular task. They used to take like 3 weeks of time. That whole thing is now updated for just a day. Within a day, you exactly know where is the code change. You just built it, test the changes on a dev environment. If it is all working fine, let your CI/CD pipeline brings it into the production environment. So faster, mean faster build time, software delivery is one of the major advantages that DevOps engineer brings in, and bug free. So if something goes wrong with production environment, when you build the code and something is off and then it broke, you can always roll back to the previous working environment, because you have a tracker, you have a version controller of what changes you just made, which broke the environment. You just roll back the changes or revert the changes to make it set back. So faster mean time and recovery time. You can build the software faster. Also, if something breaks, you can always revert it back to the in the same faster way. That is how DevOps engineer has take over the job or the work roles from all these engineers. Right now in market, you don't see a exclusive DB engineers or middleware engineers, network engineers. I think these roles are getting really less and lesser, because these are all being replaced by DevOps engineer. And if you are a DevOps engineer, you also know the software development, right? You also know how to build the code and all, right? Then you call yourself as a full stack developer. So you know how to build the code, how to write the code, how to build the code, how to test the code, how to deploy the code. If you are a full stack engineer, you're gonna do everything. So if you are a DevOps engineer plus you have a developer, you can build the software. That is how the market goes with hand in hand with DevOps and development. Here, DevOps is basically development plus operations. So you might have got it out, like what are the operations? Because except what development work that a developer does, rest all are operations. Like how we are building it, how we are testing it, how we are deploying it, how we are monitoring it, and stuff like that, right? All of them are called comes under the operations. So being a DevOps engineer, you are creating a bridge between the development and operation activities. That is how DevOps has been named. So this is the kind of intro about DevOps thing. Now let me just go back to the PPT and we'll continue from there. So we explained about prerequisites. So the companies has infrastructure engineering as well. Like I explained, right? What is infrastructure? Focusing on designing, building, and maintaining IT infrastructure, include servers, network, storage, security, support software, development, operations. Also platform engineering. So platform engineering is like, include managing your application deployment inside the infrastructure, self-service infrastructure tooling for developers. If you are a platform engineer, what you ideally do is you will create an infra as a code for your developer. So developer just kick in and start running the software inside the running their application inside the self-service infrastructure, right? So DevOps and infrastructure engineering. So more or less as an SRE basically. And then I'll just go back and quickly walk you through the DevOps thing. So DevOps is a culture. I explained this earlier. It is not a technology. It is a practice and it is a culture where you are integrating with multiple tech stack tools. Those tools are changing from company to company, project to project, right? So you are a DevOps engineer in a company A, you might be working with Ansible, but you are a DevOps engineer in a company B, you never have to deal with Ansible. You have alternative tools for it, right? Managing your infrastructure. You can use Chef, you can use SaltStack, you can use any other tools as an alternative, right? So if you are a DevOps engineer in a company A where you are working on AWS cloud, you can be the same DevOps engineer in a company B working on Microsoft Azure or Google Cloud. So it need not to be the same tool stack everywhere. So that is the reason why I kept this. So if you are a DevOps engineer, you will get to deal with some of these tool stack and not all. And then sometimes it's all as well. But there is no defined way. So what we do basically, planning, coding, building, testing, deploying, and operations. We manage all of it. That is exactly what I was explaining in here. How we do this whole thing. Now let me show you something called software developer workflow. So this is what we will be doing, right? So when we go to the DevOps engineer, you basically manage planning, coding, building, testing, deploying, and operating of your entire software. It can be any language. So you have a developer with .NET, you are a DevOps engineer, you will support. If you are a developer with, if you have a developer with, Java, C++, Python, Ruby, or whatever programming language, or whatever platform, Windows, Linux, or whatever, any cloud, AWS, Azure, or whatever cloud, being a DevOps engineer, you gonna support all of this stack because you manage the CI/CD pipeline. That is the role of a DevOps engineer. This is the same workflow I explained where developer build the code, we create a pipeline to build it, deploy it, and then move it to the stages on premises, Azure stack, AWS stack, or whatever, and then end user will be able to access it from the production environment. So these are the some of the dev stacks. GitHub, Bitbucket, AWS, Microsoft Azure in the cloud. For CI/CD, it is Jenkins or GitHub Actions, Circle CI, or Argo CD. And then infrastructure as a code is comes with Terraform, and containerization, Docker, Kubernetes, OpenShift. And then monitoring is comes with Prometheus, Nagios. And then automated testing, configuration management with Ansible and Chef. Infrastructure as a orchestration, Spacelift, internal developer platform tool like the open ops level and others. So basically the one thing that you need to understand is you gonna deal with these concepts and you will be using some of these tools. You need not to know every one of it. Infrastructure as a code, we will be learning Terraform. Like in our training, what I will be focusing is I will walk you through the Terraform, and in CI/CD we will learn Jenkins and Argo CD, and cloud providers we will be learning AWS, and version controller we will be learning GitHub and Git, and then configuration management tool we're gonna be looking into the Ansible thing, and from monitoring we will learn about Prometheus, and there is logging stack as well, like OpenShift and Elasticsearch and all. We will be learning about it, and containerization, we're going to learn about Docker and Kubernetes. So DevOps workflow, basically planning, coding, building, testing, the same thing that I explained earlier. Like, in each phase of you integrate with multiple tools. Git, Jira, I explained about Jira, Git, and build tools, testing tools, and then deployment tools and stack like that. So that's the thing with DevOps part. Now let's also have a fair understanding on cloud as well, right? So now I'll quickly go back. So since we now know about DevOps, right? So DevOps without cloud is like only halfway cooked item. Without cloud, DevOps is never been 100%, right? Because DevOps is all about automation. When you want it to automate, you need to have an infrastructure that can be elastically expandable, right? You cannot write an automation to create a second work machine in an on-premises, right? Physical machine, you cannot create it, but In cloud, it's actually elastic. Automatically, you can scale up or scale down your infrastructure. So basically, what happens is infrastructure is of three types. On-prem, where you are managing everything, a physical location with servers, network components, DB servers, database servers, and etc. So everything you are managing in your on-premises location, right? What will happen if that there is a power outage in your your UPS room? Services will go down, right? What will happen if there is a disaster happened in the location where your office runs, where all your servers are in a server room and something actually happened? You will be gone, right? So on-prem is one of the infrastructure, but there are lot of difficulties, lot of operational overhead, lot of cost included in managing the on-prem infrastructure. Then companies slowly started looking for an alternative, and they come up with the next infra model, which is virtualization. So here we have VMware. So what happens in the VMware? You have a one big server, physical server, and then you enable some sort of VMware technology on it. VTX, you enable some sort of Hyper-V or VTX or any virtualization on it, and then you create multiple small virtual machines. So what you ideally do, you set up one big machine, right? In that big machine, you install a software called virtualization. You enable a virtualization software, and you create multiple small virtual machines. With this, what is the advantage? You have this much big machine. Inside that big machine, you are creating a small virtual machines, and each virtual machine acts as a different and isolated independent machine, and you are running all your services. Here, earlier case, what happens in on-premises? You used to have big machines for your application server, and then database server, and then storage server, and then web server, something like that, right? For all your requirements, you used to use different missions in the on-premises. It's gonna be very difficult to manage it because you need server engineers here, you need different DB engineers, you need different storage engineers, you need different build and release engineers, web engineers to manage all of it. Right? It's gonna be very cost effective. Then what happened? They came up with the virtualization where they enabled one big mission and started creating a small virtual boxes inside it. Here they used to manage their app, DB, storage, and web application. All your applications are now running inside a single big mission instead of four big missions. Now this is saving some cost, right? Instead of running like four individual missions, now you are running everything in a single mission. This is called your VMware. Now there is a problem with this as well, right? It cannot automatically expand or anything. Then at over a period of time, companies started looking for an alternative because it is also cost effective, and here you need to have VMware engineers to manage your VMware stuff and all. Now companies go ahead, how about, like, this is a physical data center, somehow something happened, disaster happened, that entire data center is gone, your all your services will be down, or this is one big mission is down, all the small missions running inside it, they will also be gone, those virtual missions. So that is a problem. So then they went to a solution of cloud computing. So what cloud computing offers you? Here, you don't have to manage anything. That whole infrastructure is being managed by some cloud provider. They can be AWS, they can be Azure, Microsoft, or they can be GCP, they can be HP, they can be any other cloud provider. All you need to do is you are a end user sitting up in here. You just need a access to this cloud, ideally, and then start running your infrastructure from here. So accessing resources over internet. That is what cloud computing in a very high level, right? So you have a login portal and log into your cloud provider and start creating your application server, DB server, storage server, web server, everything you create up in here. So here, what is the advantage? You really don't have to worry about managing these servers physically. You don't have to worry about what if something goes wrong at my place. I will lose access to all my servers and stuff like that. So this cloud will have all those availability. Cloud basically offers four things: high availability for your services, security, reliability, and scalability. These are called cloud characteristics. Using these four things, you can anytime create your resource, anytime scaling it up, scaling it down, securing your resource. Always your resources are available. That is where companies found this cloud engineering is the best approach for managing their resources. And with cloud and then DevOps, it comes hand in hand in a way that you write your automation, you set up all your infrastructure in the cloud, and then you run it and then manage your resources safely. So being a single DevOps guy, if you are familiar with cloud engineering, cloud tools, so you should be able to manage all of it on your own, right? That is how cloud and DevOps work back and forth, right? So scale your resources dynamically, reduce infrastructure cost, focus on innovation rather than maintenance. That is exactly what I was explaining in my slide. If you look at this slide from 2021 to 2024, this is the market capture, right? AWS is always a market player, followed by Microsoft and Google. So they AWS has like 30 to 40% of organizations in market right now. They're using AWS. Up to 15% is being used by Microsoft. Up to 10 to 5 to 10% is done by GCP. But what cloud you choose, why you choose cloud, what is the resource you go ahead and stuff like that, we will be learning in our actual regular classes, right? So these are some of the services that you will be learning part of our training. When we go to AWS, we learn instances, Elastic Beanstalk, Lambda, ECS, EKS, S3, Glacier, EFS, other services. Like what all services required for a cloud engineer, I mean DevOps engineer to manage the things, you will be learning it in here, right? So opportunities with cloud computing, you can be cloud architect, cloud security engineer, DevOps engineer, and database engineer. So we are targeting primarily DevOps engineer with cloud knowledge, right? SRE, site reliability engineering. Now you know what is cloud engineer does, what is a DevOps engineer does. Then who is this SRE guy? What SRE does differently than a DevOps engineer? Now you know what is a cloud engineer does, what is a DevOps engineer does. Then where does the SRE things comes in? Right, site reliability engineering. So site reliability engineering is one of the practice that is being implemented by Google. Later, most of the companies started adopting it. So what SRE does is a SRE does DevOps plus observability. So in a way, DevOps role is actually 40% of SRE job. If you are an SRE, you 40% of your work is actually DevOps work, and the remaining work is all about observability. Now, what is observability? So, right, when you're, it's not just that, okay, you set up a CI/CD pipeline and then you build the application, you let your application running, and then it goes into the system and monitoring it, right? So, you have to manage its availability of that application once it is production. What is if tomorrow Flipkart goes in and then he says that, okay, we are going to announce a big billion day sale. We have offers in all the product. Come and say purchase from our site. That is the announcement from Flipkart. But tomorrow, when like like at one point of time, there are millions of users trying to hit Flipkart website. What if that website went down by the time your pipeline doesn't help anything, because it's not actually handling anything with the availability and reliability and security and monitoring and logging. These are the stacks which are very important rather than just running setting up the application. once software is actually live, you need to manage your application in a way that it is always available, it is always reliable, and it is highly securable, and you have a proper monitoring configured for your application. There is a proper logging configured for your application. These things are being done by the SRE guy in terms of observability. Here they use tools like Prometheus, Corologics, right? And then they use Elastic Search. They use Kafka, MSK or Confluent Kafka, and then other Grafana for monitoring and logging things, right? Grafana, Spunk, so on and so forth. There are these tools are like Graylog. You might have heard about the tool called Graylog for logging, managing the logging and stuff like that. So these are all the tools that an SRE uses. That these tools need not to be used by DevOps engineer. DevOps engineer would ideally set up the CI/CD pipeline using Jenkins and integrate your infrastructure, and that's it. But what SRE does is he does all of it. It manages the application once it is deployed, how you are managing it. So he set up the thing. Also, he set up the observability of your tooling. That is what SRE does. So basically, you have a product, right? So metrics and monitoring of your application, capacity planning and change management, emergency response culture and stuff like that are being managed by the SRE. So what ideally happens, what ideally happens, they all of a sudden the your website went down. You don't know the reason why, how to fix that. You need to integrate incident management and then try to troubleshoot that, find the root cause analysis of it and stuff like that, right? That is where SRE would come into place. The SRE is a guy who manages all the observability of your software. So as part of our training, we will be learning about some of the SRE components, and we're gonna deal with some of these stack that SRE does. SRE does the serverless solutions, chaos engineering, application deployment and management, infrastructure management, secret management, service mesh like Istio and stuff like that, security. These are the lot various of things that an SRE does. So SRE is not for a freshers, right? If you are a DevOps engineer, you are into system for quite some time, then you can become an SRE. So ideally, that is the whole thing about DevOps, cloud engineering, and SRE. So part of our training, how I generally do it is these are the tech stack that I generally cover, right? In AWS, I'm gonna talk about the access management, identity and access management. We'll talk about compute services like Amazon EC2, Elasticsearch autoscaling, load balancing, Elastic Beanstalk, Lambda, virtual private cloud, subnets, routing, networking, storage, database, automations using AWS, cost management, security and compliance. These are the AWS concepts you will be learning. This is like very needed for a DevOps engineer or an SRE to manage their resources in AWS cloud. So these things I will be covering, and we'll talk about Docker. So we'll talk about Docker, we'll talk about Kubernetes, setting up Kubernetes, core concepts of Kubernetes, managing workloads, networking inside Kubernetes, storage inside Kubernetes, scaling of your resources, and then Helm topics, CI/CD with Argo CD. I generally prefer Argo CD, but if you guys want, we can do the same thing with Jenkins as well. But when you are on a Kubernetes, companies use Argo CD more than Jenkins. So we will be learning about Argo CD and Jenkins. So and then we will be learning about infrastructure code like Terraform, how to write a Terraform as a infrastructure as a code, how to initiate the Terraform plan and apply things, stuff like that, right? So these are the course items that I will be working through in my course. So once you are done with the course, you can be eligible for DevOps engineering, cloud engineering, and if you have a prior experience with DevOps, I think you can be fit for SRE as well. That is how I generally target. More than this, what I kindly, I mean, kind of prefer is getting a AI enabled thing. Right now, every organization they use AI enabled stacks. Like Copilot we use, and then AWS Code Whisper we use, and then GitOps. These things I would be prioritizing. I don't generally want to do the legacy things which are not really in use, which won't actually help you as well with the current speed of technology changes. You should be learning a tool, and you should be learning how AI enabled that tool is. So Copilot, uh, AWS Code Whisper, you will be learning, and then using ChatGPT, how we can make use of, how we can make use of ChatGPT in and out of our DevOps practice is something we will be learning during our course.